Okay, here we go. We're recording brief, but important notes on 3-2. Marvin, do you have paper out? Okay, good. And I'll post this on Google Classroom as well. Now, last year you had linear functions. We're going to just take that a little bit further this year. You had last year y equals mx plus b, where m was what? Can't remember that part? Yeah, slope. Good, Chris. M is the slope. Now, we're in hand-raising mode and note-taking mode, so please just be writing. Those of you that have tunes in, they need to go away. Thank you. Okay, this is really important. M was the slope, and what was B? What was B? We had that last year. Yeah, that's called the y-intercept. And we're going to expand that this year. We're going to expand that this year just a little bit. And rather than call it the slope, we're going to give it another name, and the y-intercept another name. That makes it a little more broadly acceptable for other applications. So rather than, and the slope is still very valid, totally. But rather than just, and y we talked about in last section, we can talk about it in terms of f of x equals, and then instead of slope, I'm going to call this the common difference times some x value. And again, that was the slope. And then we're going to go plus the initial condition, and that allows us to talk about these linear functions really broadly about many different things. Okay? And we're also going to look at this from a tabular standpoint. So if we have x and f of x, a function of x. And again, sometimes when we get started with that function notation, you think that's f times x, but it's not. It's a function of x. And let's say we have values like 2 and 3 and 4 and 5 and 6 and 7. And then we might have -8, -5. That is not a good 5. I'm going to fix it. -8, -5, -2, 1, 4, and 7. We could have values like this. Now, we might say, right, white, I am having something for breakfast. Write an equation to model the data. Okay? So step 1, find the common difference. Find the common difference, okay? In this case, what's the difference between any of these two entries in my table? Phoenix, what do you think? What's the difference between any of these two entries in my table, Phoenix? Well, what's the difference between 7 and 4? 3. So you do know. What's the difference between 4 and 1? Yeah, the common difference then is 3. And that is going to be my slope in the old system. Just if you're thinking of it graphically, that's my slope. In the warm-up, it was 4 and 3. In this one, it's going to be 3 and 1 will be my slope. Much steeper, a much greater rate of change. Next up, step 2. Step 2, find the initial condition also known as the y-intercept or f of 0. Yeah, because at the y-intercept on any graph, like right here, and I'm going to change this. I'm going to change this to reflect our slope for this new one we just did. On any graph where it crosses the y-axis, yeah, where it crosses the y-axis, what is the x value right here, Shay? What is the x value right here? 0, of course. You said like you're in pain. Yeah. Okay, right there, x equals 0. So y equals f of 0. F of 0 right there. And then, Marvin, you were talking about the slope before. Our slope in this case is a change of 1 in the x direction and a change of 3 in the y direction. That's where that common difference came from. Common difference. Okay, we're almost done. Y'all are doing an amazing job, and I am going to quit here in a minute. Okay, so we found our common difference of 3 because for every 1 that we changed up here, it changed by 3 down here. Common difference. Find the initial condition. In other words, what happens when x is 0? Now, sometimes you're going to have to add more out here, and that's fine. Just add more. Big deal. So we have 2. There's 1, and there's 0. Okay? So when this is 1, when this is 1, when x is 1, what's y going to be, or f of 1? Who should I pick on? Gunnar, how are you? I'm good. I feel good when we're doing math. So, Gunnar, what is f of 1? Brandon, we're good. What's f of 1? Well, follow this pattern. 7, 4, 1, -2, -5, -11. According to your calculations, -11 is right. Very good. Very good. Okay, Brandon, bring it home. Yeah, no, tell me. It's good. It would be -14. It would be -14 is my initial condition. Okay? So, that is perfect. Thank you, Brandon. Thank you, Gunnar. -14. Now we're ready to put it together. Step 3. Write the model. This is the exciting part. This is the big payoff here. Gabe, what do you have? Write the model for me. F of x equals But you do have it down. It's right here. It's done for you. You just have to express it a little bit differently. F of x equals, I suppose I should go green on that. Okay, we're not yelling across the room right now, Brandon. F of x equals 3 Remember, this is going to be a linear equation in this form right here. No, you're not. You're doing great. Let's put it together. F of x equals 3. No, you're fine. Leslie, can you help him out? What's the other part here? Minus 14 is correct, but we left out one thing only. One thing only.
Let's say we're equal to. Greater than or equal to.
Jonathan? X. Just X.
What? Oh my gosh.
Okay, f of x equals 3x minus 14. That is this table right here in symbolic form. We have the common difference. We have the initial conditions. And we're good to go. All right, I'm going to stop the video and have you do one just like this. So, yeah.